In this next example, we are given a weekly data of number of breakdowns of equipment of logs engineering. And here, the management wants to determine whether some of the breakdowns that happened were anomalies or unacceptably high. In this particular example, we will use C chart, which is an attributes control chart with the data collected in subgroups that are of the same size. C charts show how the process measured by the number of non-conformities per item or group of items changes over time. Non-conformities are defects or occurrences found in the sampled subgroup. They can be described as any characteristic that is present but should not be, or any characteristic that is not present but should be. C charts are used to determine if the process is stable and predictable, as well as to monitor the effects of process improvement theories. So to begin, let us direct our attention to this section here. To be able to compute the values for the control line and the control limits, we first need to get the average number of equipment breakdown as well as the standard deviation. For this one, we simply get the average of the breakdowns. Then for the standard deviation, we just get the square root of this average. As in the previous example, you are given here a drop-down list for the confidence level. So for now, let's retain the 95% selection. Moving back again to the table, let's add 3 columns, 1 for the control line and 2 for the control limits. The control line is simply equal to the average value. The lower control limit is simply equal to the average number of equipment breakdown minus twice the standard deviation if the confidence level is at 95%. Let's put it in here in this if formula. Otherwise, it should be the average less 3 times sigma. So let's just reduce the number of decimal places. Now for the upper control limit, same as what we've done for the lower control limit, we'll just use addition instead of subtraction. So here, let's type again, if the confidence level is equal to 95%, then the upper control limit is simply equal to the average plus 2 times sigma. Otherwise, it's equal to the average plus 3 times sigma. To create the C chart, let's highlight The 4 columns here, go to insert, then choose insert line chart. Then let's just reformat. So include the title here. Then let's remove the grid lines to make the chart cleaner. Change the color of the lines. Just follow me as I edit the chart. Change this to red. Dotted lines. Same as with control, the lower control limit. So here, given the observed breakdowns across the different weeks, we can see that there were breaches sometime in week 7 as well as in week 10. And notice also that for weeks 5 through 10, in general, the breakdowns are above the control line. So given the results, there seems to be unacceptably high number of breakdowns in the equipments of logs engineering. So this is how you can create a C chart in Excel.
Here are some key things to look for in control charts. Any point on or outside the control limit is considered abnormal and requires investigation. There is a shift when points lie continually on one side of the control line. There is a trend when there are 7 consecutive points in a continuous upward or downward direction. When most points lie within the center and 1.5 sigma, it usually indicates the mixing of data from different populations, makes the control limits too wide, and stratification of data necessary. Any repeated, consistent up and down cycle is abnormal and requires investigation. Lastly, 2 of 3 points lying outside 2 sigma is considered abnormal.